Good morning, everyone. In today's class, we are going to study an important topic in dairy technology known as tropical dairying. This topic explains how climatic conditions influence dairy farming systems in tropical regions. In this session, we will understand the concept of tropical dairying and its climatic influence in a clear and systematic manner. To begin with, let us look at the basic concept of tropical dairying. Tropical dairying mainly occurs in regions experiencing high temperature and variable humidity. These climatic conditions create a challenging environment for dairy animals. Most dairy systems in the tropics are based on smallholder farming. They usually depend on low input systems and crop residue based feeding. Zebu cattle and buffaloes are the dominant dairy species in these regions. They are preferred because of their better heat tolerance and disease resistance. To understand this topic better, we must first understand what is meant by tropical climate in dairying. The tropical belt lies between the Tropic of Cancer and the Tropic of Capricorn. These regions receive intense solar radiation throughout the year. As a result, animals are exposed to high solar heat load. This increases the risk of heat stress. Seasonal rainfall is another important feature. Wet and dry seasons affect fodder availability and quality. High humidity further complicates the situation by reducing the animal's ability to lose heat. Overall, tropical dairying operates under hot and humid environmental conditions. Let us now focus on the key characteristics of tropical climate that influence dairy production. One major characteristic is high temperature. Ambient temperatures often exceed 30 degrees Celsius, which is above the comfort zone of dairy cattle. Another important factor is high humidity. Elevated humidity reduces the efficiency of evaporative cooling through sweating and panting. Seasonal monsoon rainfall is also common. While it supports crop growth, it creates wet conditions that affect fodder quality. Heat waves further intensify thermal stress. These conditions directly affect feed intake and milk synthesis. With this background, we can understand how high temperature affects dairy animals. When ambient temperature rises beyond the comfort level, animals experience heat stress. Due to heat stress, feed intake is reduced. Dry matter intake may decrease significantly. Animals show physiological responses such as increased panting and rise in body temperature. Although these responses help in heat dissipation, they consume energy. As a result, milk yield declines. This explains how thermoregulation failure leads to production loss. Along with temperature, humidity also plays a critical role in milk production. High humidity interferes with evaporative cooling. Sweat does not evaporate efficiently from the skin surface. Because of this, body heat gets trapped and stress is intensified. The temperature-humidity index, or THI, rises beyond safe limits. When THI exceeds 72, animals experience severe heat stress. This leads to a noticeable reduction in milk yield. Thus, humidity amplifies the negative effects of high temperature. Another important aspect to consider is the effect of tropical climate on milk quality. Under tropical ambient temperatures, bacterial growth in raw milk occurs very rapidly at ambient temperatures. Milk can spoil within 3 to 4 hours at around 30 degrees Celsius. Bacterial multiplication is much faster in warm conditions compared to chilled milk. This directly affects milk safety and shelf life. Therefore, clean milk production becomes extremely important. Immediate chilling to 4 degrees Celsius is the most effective method to control spoilage. Let us now examine the major constraints faced in tropical dairying. Heat and humidity stress is the most significant constraint. It reduces appetite, alters metabolism, and lowers milk yield potential. Feed and fodder scarcity is another major issue. Seasonal variation in green fodder availability leads to nutritional deficiencies. Disease prevalence is also higher in tropical climates. Warm and humid conditions favor bacterial and parasitic infections, such as mastitis. Reproductive problems are commonly observed. Heat stress affects fertility, conception rate, and embryo survival. To overcome these challenges, specific management interventions are followed in tropical dairying. Providing shade and proper ventilation helps reduce heat load on animals. High roofs and ridge ventilation improve airflow inside animal housing. Timed feeding is practiced during cooler parts of the day. Feeding early morning or late evening reduces metabolic heat production. Clean drinking water must be available at all times. Adequate water intake supports thermoregulation. Early milk chilling and strict hygienic practices help reduce bacterial growth and disease incidence. This slide presents a visual summary of tropical dairying and climate interaction. Tropical climate leads to temperature-humidity stress in dairy animals. This affects animal health, milk yield, and milk quality. Appropriate management practices help mitigate these effects. An integrated approach ensures sustainable dairy production under tropical conditions. Finally, we come to the end of this session. Understanding tropical dairying concepts is essential for achieving sustainable milk production in hot climate regions. Thank you for learning. In the next session, we will move on to the topic of clean milk production.